Hello everyone. I'm going to do an example of how to find the coordinates of the orthocenter in a triangle on the coordinate plane. So first, the orthocenter is the intersection of the altitudes of the triangle, and the altitude is going to be the segment that goes from a vertex and then is perpendicular to the opposite side of the triangle. So let's start by graphing our triangle XYZ. So I have my vertices here. So x, negative 5, 1, 1, 2, 3, 4, 5, and then down 1. Y is the point negative 2, 4, 1, 2, and then all the way up to 4. So it looks like about here. And then our last one, point Z, 3, negative 1, 1, 2, 3, down 1. Okay, let me connect these together to get our triangle. So each of the vertices of this triangle is going to be sort of our start point for our altitudes. This is x, this is y, this is z. Alright, so each of the vertices will be the start of one of our altitudes. The other thing we need to make it an altitude is it has to be perpendicular to the opposite side that from that vertex. So within the coordinate plane, the easiest way to make sure that something is perpendicular is to make sure that their slopes are opposite reciprocals. When slopes are opposite reciprocals, we know that those lines are going to be perpendicular, and it's going to make the right angle that we want. Okay, so one of these segments is easy to start with. So XZ, this is a horizontal segment. The only thing that's going to be perpendicular to a horizontal is going to be a vertical. So from Y, if I just draw in the vertical segment, I know that's going to be perpendicular to XZ. So Y is at negative 2, so just straight down through x value negative 2. So that is our altitude here. So that makes the right angle. Alright. Now I need to do an altitude from one of the other vertices, either from x or from z. And I need to make sure that it is perpendicular to that opposite side. So let's take a look at the segment YZ. And I'm going to find the slope of that segment. So slope, the slope formula, we subtract the y values in the numerator, and we subtract the x values in the denominator. So for y and z, our two y values, I have negative 1 minus 4. And then the two x values, making sure I go in the same order here, so we have 3 minus a negative 2. So up top here, that's going to be negative 5, and then minus negative 2, that's going to turn into 3 plus 2, which is positive 5. So we have a slope of negative 1. If my slope is negative 1, the perpendicular slope to that is going to be the opposite reciprocal. So two parts there. Opposite, we need to switch the sign, and reciprocal, we are going to flip the fraction. So that's going to turn into positive 1. So I know the slope of my altitude is going to be positive 1. So I can start from my vertex x, use that slope of positive 1, go up 1 over 1, up 1 over 1 here, and if I keep doing that, that's going to give me some points that are going to be on the line, which is my altitude for this triangle. So we go up 1 over 1 again, and up 1 over 1 here. And if I draw on the line, that is our altitude. Looks like I missed a little bit there. But because this slope is negative 1, and this line that I just drew in has a slope of positive 1, I know that they are perpendicular here and form that right angle. So where these two altitudes intersect, that is going to be our orthocenter. Again, just like our other points of concurrency, if I wanted to, I could do the third one, but we know that all three of these have to meet. So the altitude from Z also has to go through that point. So we can draw it in like so. So that's our orthocenter there. And that looks like we have coordinates of -1, 2, and up 2. So our orthocenter is the point -2, 2.